Welcome to the class. In this video, we'll solve some problems based on adjoints and matrices from textbook. So let's start. The first question is, find the adjoint of each of the matrices in question number 1 and question number 2. Question number 1 is A is equal to 1, 2, 3, 4. So first we'll find the cofactors. A11 will be equal to 4. A12 is equal to -3. A21 will be equal to -2 and A22 will be equal to 1. So cofactor matrix will be 4, -3, -2, 1. So adjoint of A is equal to transpose of this. Rows will become columns. 4, -3, -2, 1. This is the adjoint of A. Now question number 2. A is equal to 1, -1, 2, 2, 3, 5, -2, 0, 1. Now let us find A11. A11 is equal to -1 to the power 2. This determinant 3 minus 0. A12. A12 is equal to this. A13. Now A14. A31. A21. A22. A23. A31. A33. Now the cofactor matrix will be 3 minus 12, 6, 1, 5, 2, -11, -1, 5. Now adjoint of A will be the transpose of this cofactor matrix. That is, the first row will become first column. 3 minus 12, 6. Second row will become the second column. 1, 5, 2. And the third row will become the third column. -11, -1, 5. So this is the adjoint of the given matrix A. Now in case we have to find the inverse of this. For that you have to find determinant of A. Determinant of A is equal to A11 into A11, A12 into A12, A13 into A13. So it will be equal to 1 into 3, -1 into -12, 2 into 6. 3 plus 12 plus 12 equal to 27. Determinant of A is equal to 27. So it means that A is not a singular matrix. So inverse can be found. So A inverse is equal to 1 by determinant of A into adjoint A. 1 by 27 of the adjoint, and adjoint was 3, 1 minus 11, -12, 5 minus 1, 6, 2, 5. This is the inverse of A if you have to find it. Now next question. If A is equal to 3, 1, -1, 2, then show that A square minus 5A plus 7I equal to 0, where I is the identity matrix of the same order as A. So let us find A square first. This is the value of A square. 8, 5 minus 5, 3. So now let us simplify the LHS first. LHS is equal to A square minus 5A plus 7I. Now we have found the A square. This -5 will multiply each and every element of the A. -15, -5, 5, -10. I is the identity matrix of 2 by 2 order, 1, 0, 0, 1. Now the sum will be equal to, we'll add the corresponding elements. 8 minus 15 plus 7, first element. Second element will be 5 minus 5 plus 0. First element of the second row will be -5 plus 5 plus 0. Second element of the second row will be 3 minus 10 plus 7. 8 minus 15 plus 7 will be 0. Second element is also 0. Third is also 0. Fourth is also 0. So it is a null matrix of 2 by 2 order. It means that this. So LHS equal to RHS. This is the RHS, the null matrix. So LHS is equal to RHS verified. Now using this result, we have to find the A inverse. What was the result? A square minus 5A plus 7I is equal to the null matrix. Multiplying both sides by inverse from the right side, a square minus 5a plus 7i into a inverse o into a inverse. The left side will again become o and the right side will be a square a inverse minus 5a into a inverse 7i into a inverse. Now it will be equal to a minus 5i plus 7a inverse is equal to o. Now a is equal to 3 1 minus 1 2. I is the identity matrix of 2 by 2 order 1 0 0 1 plus 7 a inverse, which we have to find equal to o. Now distributing 5 to the identity matrix will get minus 5 0 0 minus 5 plus 7 a inverse equal to o. Adding these two will get minus 2 1 minus 1 minus 3 plus 7a inverse equal to o. Transposing to the other side, 7a inverse is equal to o minus 2 1 minus 1 minus 3. 7a inverse is equal to 2 minus 1 1 3. A inverse equal to 1 by 7 2 minus 1 1 3. So this much only in this video. In our next video we'll learn about application of derivatives and matrices. Until then, keep learning.